Good evening, everybody. It's a pleasure to be here this evening. For those of you in person, for those of you live streaming, I'm Linda Bell. I am Provost and Dean of the Faculty at Barnard. And it's my pleasure to introduce the annual Distinguished Lecture series for the Department of Computer Science, which celebrates the achievement of women in computer science. But it is an even more special event this year. First of all, the disruption of last year. Secondly, the college celebrates Barnard's what we're calling the Year of Science, which is aimed to draw attention to our excellence in STEM. And September is not by chance, because this was worked out this way, focused on computer science and mathematics. Our speaker's scholarship actually fits closely with another overarching theme of the Barnard Year of Science, which is connecting to the cosmos. What is the planet's destiny? As the connection here is partly about the destiny of humanity, as well as AI's role in advancing the study of our planet and of the universe. As Professor Wright will be formally welcoming our speaker, I'll only say that we're thrilled to have the Dean and Professor Ayanna Howard here with us tonight. And now just a brief, tiny bit about computer science at Barnard before I turn it over to Rebecca. We formed our program in computer science in 2019. And as we continue to build the faculty, our students have eagerly flocked to the subject. Computer science is currently one of the top 10 majors at Barnard. And many more students explore computing through various classes that connect to computer science and through the Vagelos Computational Center. And all this couldn't have happened, or definitely not nearly so well, without the strong support of true partners at Columbia Computer Science, who've helped with curriculum, but most significantly with the recruitment of top faculty, including our inaugural CS director and chair, Rebecca Wright. And with Rebecca's superb leadership, computer science has grown in other ways. It participated for the first time in Barnard Summer Research Institute with 24 sponsored students this summer. It participates now in a very unique 4+1 BA MA pathway with Cs, which is proving incredibly popular, also drawing all kinds of wonderful students who are applying to Barnard. And that first cohort of C's graduates is scheduled to graduate this year from the master's at C's. So these 4+1 programs are really fabulous and rely on the same kind of partnership with the university that I've been speaking about. So I could go on, but we've built a lot on Rebecca's shoulders. So I'll stop here other than to say a big thank you to Professor Wright and to her colleagues in CS, and to offer my warm welcome to our distinguished speaker. Rebecca.
Testing. All right, thank you, Provost Bell. Let me add my welcome both to those of you who are in the room and those of you who are on the Zoom. This is our first large hybrid event, so there are a few glitches and I apologize for them, but I think you're probably all familiar with what this last year plus has been like in terms of having to learn new modalities and adapt. It's really exciting to be back on campus with our students and our faculty. And our hope is that we can take what we've learned about how to use technology to share information and increase access, such as having this event still be held on Zoom, while also safely re-engaging in the richness of in-person connections with each other, and hence the part of the event that is here in the room. A few announcements related to that, since this is all new for us. So the microphones that are in the room are designed for kind of in-class participation. So they will pick up the people in the Zoom. If you're having a conversation sitting at a table in the room, you might be heard. So just know that. Ideally, don't have those conversations thinking that they are private. And if you are on the Zoom and you do hear what you might hear in a normal classroom situation, a little bit of rustling of papers or perhaps a whisper or something like that, just know that that's what it's like to be at an in-person event, and you get to participate in a little bit of that part of it. So also for the in-person people, in the name of keeping everyone safe, we do have a list, a paper list we've asked you to sign in on before you leave if you haven't already, in the event that we do need to do any kind of contact tracing so that we can reach you that way. So I'm not even fully on the camera, am I? I'm good enough. So now I am particularly excited for this year's Distinguished Lecture in Computer Science that Dr. Ayanna Howard is joining us in person. She joins us from the Ohio State University, which she recently joined. She is the Dean of Engineering and the Monte Ahuja Endowed Dean's Chair. She also holds a faculty appointment in the college's Department of Electrical and Computer Engineering and a joint appointment in Computer Science and Engineering. She was previously at Georgia Tech, where she was the Linda J. and Mark C. Smith Endowed Chair in Bioengineering and also Chair of the School of Interactive Computing. Earlier, she was at NASA, where NASA's Jet Propulsion Laboratory, where she held the title of Senior Robotics Researcher and Deputy Manager in the Office of the Chief Scientist, and she designed technology for Mars rover missions. Her research encompasses advancements in artificial intelligence, assistive technologies, and robotics, resulting in over 250 publications to date. She founded Robotics, and an education technology startup that designs AI-powered tools and learning games to engage children with diverse abilities in STEM. And she has many awards. I won't list them all here, but some of the highlights are an IEEE Fellow, a AAAI Fellow. She's a recipient of the Anita Borg Institute Richard Newton Educator AB Award, the CRA A. Nico Haberman Award, the Richard A. Tapia Achievement Award, and the NSBE Janice Lumpkin Educator of the Year Award. She also serves on the board of directors for the Partnership of AI and Autodesk. She was recognized, again, more places than I can list, but she has been among them recognized as one of the 23 most powerful women engineers in the world by Business Insider, as well as one of the top 50 women in tech in US by Forbes. And also, and I think this one's particularly cool, she functions as an AI advisor on the YouTube Future of AI documentary series produced by Robert Downey Jr. I've had the pleasure of serving with Dr. Howard on the Computing Research Association's Committee on Widening Participation in Computing since 2012, and I've just been so impressed with her commitment to increasing diversity in computing and access for everyone. So please join me in welcoming Dr. Howard to talk to us about making the world better through robotics and AI.
Thank you. All right, so what I'm going to talk to you about in this time that I have with you is really kind of three areas. I want to walk you through my journey because I think a lot of times we don't hear about the journey that led to the technology. And for me, it was especially important because the journey itself is what led me to thinking about the technology the way that I think about it. It led me to even choosing the types of research and projects that I was passionate about was because of that journey. And then I want to talk a little bit about where I see AI in terms of these novel nuggets that I'm really excited about. And then lastly, talk about some of the things I worry about as well. So with all opportunities and advancements in AI, there's also things that I think we as a community need to lean into and really think about. And I will weave throughout this elements of research because I am an academic, so I still do research and kind of show you and share with you a little bit on that. And so a beautiful introduction, thank you. You know, what I want to start off with are, and I always start off with this aspect, especially when you are an applied researcher and you work in applied AI, is these are the credentials. And so a lot of times when you're the first or you're one of very few, there's always this assumption when you walk into the room that you are not quality. And so I always learned from very early on that you show your credentials because those are the things that people can't take away from you, right? Your computer science degree, no one can take that away from you. The research that you do in a lab, no one can take that away from you. And so anytime I really start talking, and now I just do it because I like it, but earlier on, it was always that you had to prove yourself. And I learned that if you just showed your credentials from the very beginning, you wouldn't have to navigate that. And unfortunately, it typically happens when you're the one and only, or you're the first, because there's an assumption that that's not applied to you. So these are my credentials, which again, I'm proud of, but I wanted to show that to tell you that story about there are things why I love education that no one can take away from you. And so claim those, value them, because they're the one things that you can basically build on. Now, the other thing with credentials though, and these are the things that were inherited, are the labels. And so a lot of times when you're in the world, you do have labels. So two of the labels that were mentioned, which I'm very proud of. So people label you, best technologist, high impact. These are labels that other people apply to you. It's not necessarily that you decide that, okay, this is the label that I want. I'm going to write the magazine and say, can I have this label, please? Put it in a magazine. Thank you. These are labels that others bestow on you. And the fact is that people will always add labels to you. They will always define you based on their perception of you. When it's early on, it might be, for me, there is a Black woman versus a computer scientist, right? For others, it might be, oh, they have a very strong accent versus being an engineer. And so the world will label you. And therefore, one of the things you should always think about is, given that the world is going to label you, choose the ones that resonate with you. So these are the labels that I've chosen because they resonate with. And I have a lot of other labels that didn't resonate with me, and I put them aside and I put them under the door, but these are the ones that resonate with me. And I chose, basically, as a point of empowerment, I chose the labels that others have given, but that I felt very comfortable with. Now, one label that's up here is the nation's most senior African-American female roboticist in higher education. And I remember when that label came out, and I was actually a little bit offended because that implied that I was old, right? And then I thought, well, I don't know if I really want that label. It says that I'm old, and even though maybe I'm a chief, it sounded so old. But then I thought, I think I don't look that old. And I decided that I was going to take that label because when I say that, like, I'm the most senior African-American roboticist, in some cases, the most senior African-American female AI person, it's shocking sometimes. It's like, wow, well, how long have you been doing this? I've been doing it for a while, but it's like, but you don't look that old. And then somehow that conversation is, yeah, isn't it a shame? Right? And so I chose that label because it allows me to have a conversation, even though I don't think that I'm old. And so when you think about your labels that people are going to bestow on you, choose the labels, one, that resonate with you, but you might also choose the labels that allow you to have a conversation, that allow you to have an exchange about certain things, that allow you to really think about this. And so why I present this and why I talk about labels and this aspect of credentials is that it leads into my thinking and my processes about AI. And I'll talk about the things that I worry about later on. So my journey began, I was a NASA robotics researcher. My very first journey, I finished my PhD. I've been at NASA every summer. They paid for my master's, they paid for my PhD. And so I had my very first job. So I'm 27, I go in, my supervisor's like, okay, now you don't have to go to classes anymore, you don't research. I have this idea and I have this team, I need you to be the technical lead for this. And it's like, okay, I'm excited, what is it? And he's like, well, we're thinking about the next rover mission to Mars, and we like to do something called long-range traversal. So this is, we want to put the rover on Mars, we want to be able to navigate without being able to see where we're going. So over the line horizon navigation. And I was like, okay, I need to look at the books, where's the theory behind it, I'll just apply it. And it's like, no, this is on you, you got to figure it out. And there's other teams, by the way, right? Because the way it works is you have research, and so you have other teams that work on other ideas. It's like, go at it, figure out who your team is. And so I sat back, first of all, I was like, are you sure? Like, are you really sure? Like, this is like a big deal. It's like, yeah, I trust you. I think about I like how you think. I trust you. I know you're gonna come up with something crazy because that's the way you think. Go on your way. And what I did is, I sat back and I thought about, what are the things that I value? What are the things that I think about? What are the things that are important? And I decided that what I was going to do, which again, now is not novel, but back then is, as an engineer, computer scientist, what I was going to do is I was going to go to the experts who were the scientists. And what I was going to do is figure out, how do I get what the experts do as the experts and make it so that they were input into the rover systems. Versus traditionally what would happen is as engineers and computer scientists, you'd be like, oh, I think I know how to do this. Here's the algorithm. Let's deploy. Let's send it off. Oh, look, isn't that amazing? Scientists, please use our tool. And so I decided to reverse it and say, no, 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 let's have the human scientists as core. And what I was a tool that enabled them, which was a little bit different because it meant the scientists had a lot more power than the engineers and computer scientists. But one of the things that allowed me to do is one, it learned that scientists have a different language, by the way. And what I had to do is I had to adapt myself and my team to understand them versus requiring them to understand us as computer scientists and engineers. And what happened was it was an amazing success. Even though in terms of the thinking about the training, thinking about getting out the comfort zone, going to them and trying to figure out what they were talking about and why was this important and why should I care, really caused my team to have to be uncomfortable. But at the end of the day, it was an amazing experience. And we applied that. And so when anyone came to my team now, it was like, Ayanna, we have no idea how to do it, go at it. And my whole thing was, who is the human expert? And how do I design algorithms to get what's in their head, to get what's in their practice into the rovers as an algorithms? And that was a special sauce. And at the end of the day, you would look at the algorithms. And if you looked at them, you're like, that's actually pretty simple. You see a rock, you turn left. Like, why is that novel? But then the concept is that if you actually open up the hood, the thinking process and how you even decide to turn and what rate and what angle was all derived from people actually navigating in the space and people telling us and actually acting out these roles that we then decoded. And of course, then it becomes simple. And as you know, the best technology are the ones that seem obvious at the end. And that was a special sauce. Fascinating, loved it, was amazing. And that's what I became known for, like the person that liked people. And she could figure out how to work with these strange people like scientists and figure out how to encode their knowledge to do these amazing things. And so when I went to, so I was at NASA many years, that's what I did. We did basically landing rovers and anything in between. So I came to academia, a long story, we can talk about it later. I didn't know what to do. I was a robotics researcher. I knew space and I knew NASA was not going to give me a project to design rovers for Mars. And just so you know, I did ask, right? So this was not me just imagining. I actually did ask, like, hey, Georgia Tech. They're like, yeah, that's funny. And so I had to figure out what was I going to do? This is what I knew, I knew how to do this. I knew rovers, I knew hazardous environments. This is what how do I take that and translate it? And I actually went out and talked to a bunch of scientists. I was like, you know, I'm an engineer, computer scientist for hire. You're a scientist, you know, what can I do? And I actually found a young scientist who was a climatologist. And we got to chatting and he would go to Antarctica basically every other year and collect sensor data. So what he was doing, this was back in the day when climate change was not a known. And that's basically what he's working on. He's like, you know, one of the really big problems I have is that when I go out, there's these weather stations that are out there and they're just really sparse. And I have to create these models based on this really sparse data. And, you know, could you do something like maybe you can like dig underneath? And I was like, wait, no, data, sparsity. You need data in between. Rovers for Mars, rovers for ice. This sounds like a brilliant idea. And he was like, sure, maybe. But we actually then pitched it to NASA and NASA's like, oh, that sounds interesting. Earth science, we do fund Earth science. I think maybe you can do it because, you know, no one at NASA really wants to do Earth science. So yeah, I think we'll do this. And so that was the whole goal. So this is one of our field trips out to the glacier. Now walking through this and why, again, thinking about how do you do this? And this is a lesson learned of when you have this expertise and you have this experience, how sometimes when you're in a different space, you fail to actually apply it the first time correctly. So our very first project, we designed, this was called the spider motes. So what happened was we're trying to think about how do you design rovers for these glacier environments? And so, you know, my team, which was basically students, research scientists, like, okay, how do we do this? How do we do this? And we thought, oh, we are going to create these leg vehicles, right? So we're going to deploy them called spider motes. We actually had the sensors, we designed all the algorithms, and we were like, okay, and then we're gonna go out. And then what happened is after we built basically a suite of these things, and we tested them in the lab, they were perfect. They worked really, really well. We took them out. Now, I'm at Georgia Tech. If for any of those who don't know, Georgia Tech is in Atlanta, Georgia. So there really wasn't any snow. So we actually had to drive. And so we rented a generator and we hauled all the equipment and we went out. And we found the snow and we deployed them. And we're like, okay, of course, you always have to have the video camera. So anytime you have rovers or robots, you always have the video camera on so that when they work, that's what you post on YouTube. So we had the cameras on, we're waiting, and they were walking out and we're like, oh, look, they're navigating, they're communicating, they're actually doing all of this multi-agent formation. And as they were walking, their little legs slowly descended in the snow. It was beautiful snow angels. And I remember looking at my students and they looked at me like I should have known this. And you know, one of the things is I at that moment, I realized, so I came from California, I was in Atlanta, Georgia. My team, I had a student from Argentina, one from Spain, I had Texas. The common theme is that none of us grew up in snow. And so we didn't even think about the fact that here it is, when you have legs and you have these thin, basically points of penetration in snow, that walking on snow is probably not a good thing. And I thought, it's like, why didn't I talk to the scientist about this? And I hadn't talked to the scientist, right? The scientist was doing his design and we were talking about the sensors and things like that, but I didn't talk about the platform. And I thought, this was my experience. This was my secret sauce. Why is it when I was put into a different environment, I forgot the lessons that I learned? And so we rebooted and we like, okay, we need to go back. And we talked to the scientists like, well, what do you do? And then we talked to other scientists. We called, we looked at YouTube videos and realized that scientists do walk on glaciers and they wear snowshoes. And I will tell you, and I don't show this, we actually created, you know, basically snowshoes for robots. That was a fiasco, disaster. But we finally got to the point where we designed the snow modes. And at the end of the day, it's like, that's obvious. Of course, snowmobiles, and you just add robots, you have the algorithms, you have the sensors, like, that's brilliant. But the fact is the design came from working and designing from our own lessons, from our own knowledge base, not going out, even though that was a secret sauce, and then transitioning, failing, before we finally realized that the special sauce is making sure that we had a diverse viewpoint on the team. And that's really what it is. And so when I think about diversity, at this point, I started to think about really seriously about this word diversity. And a lot of times when we talk about diversity, it's very easy to say, oh, we just need to bring in female engineers and computer scientists. And oh, good, we have a team and there's 2 out of 100. Awesome. Or you bring in someone who is a racial or ethnic minority based with respect to a majority demographic. We say, that's diversity, cool. But really what we think about when we're designing innovation and we're designing these creative things is that what it is that we need different mindsets to be in the room to have a conversation. And the fact is as a female, you might come in and you have a different viewpoint and contribute to that conversation. Yes, that's diversity, but if you are also someone who's from a high social economic viewpoint, in a room with other individuals that are also high middle class, and you're trying to solve a solution of something, your viewpoint might not be as diverse as you think, depending on what it is that you're addressing. And so I always think about this now when I think about diversity. It's easy to say racial, ethnic, or gender diversity, but it's actually much more than that. And when we design teams, and even now when I think about projects, I put students together, I'm actually looking for that difference of thought. What was your background? And for students that I've talked to, I always ask, where are you from? How did you grow up? What did your environment look like? Because that allows me to figure out what is your mindset and how can you contribute a different mindset to this conversation so that we can innovate. So that was beautiful, that was amazing. That continued on, design algorithms for under ice, rovers that would explore underneath the Arctic shelf. Again, amazing, amazing, amazing. But one of the things that I started to find was as the scientists came, so the scientists now, Earth scientists were like, oh, there's a team at Georgia Tech and they're cheap and we can work with them and they give us what we want. And so that came, and there was many different types of projects. And one of the last projects was an interesting one where a group of scientists were coming and they said, we work with these aquanauts. I was like, I had never heard of aquanauts, even though I've been at NASA. He's like, and what we're trying to do is we're looking at how do we do, basically handoff kind of science when we go to the space station and eventually the moon and Mars. And, can you work with us on this domain? And so this was the first time where instead of having scientists be the experts in terms of the knowledge, that I had the robots working in the same space as people. And that enlightened me to the fact that I really do like people, right? Like it was such a fascinating experience to just be there and seeing people interact and going like, why did they do that? That makes no sense. And trying to model it and think, wait, like I had A, B, C, D. Why did they do A, B, E, D? That makes no sense. And I felt such a fascination and a curiosity that I decided literally, basically with the switch was like, I want to go down this path, this whole human robot interaction, human AI interaction. It's fascinating. And if I read all the literature, no one understands it either. And so I decided at that point, again, from this project, that this was something that I was going to pursue. Now, I didn't know anything about this space. Like I worked with humans, but as experts. Humans and agents in the same space was something new and something different. And so I had to figure out what this was, like, what is this going to do? And for those of you who will continue on to grad school or in PhD programs at some point, there's something called a thesis. And at the end of your thesis, there's always this chapter called future work. Now, as a student, what you'll find out is the future work is always like your dream science fiction jobs, because if it was real, then your advisor might say, oh, you can do this. Like, it's only going to take you a month. And so you really basically think of like, what cannot be done in the year that's left. And so I decided, because my thesis had been on a combination of early computer vision and AI, machine learning, I decided to look and see, maybe I had some really good ideas that was in that chapter. And it was actually in healthcare robotics, which again, wasn't really interested in healthcare robotics. I was in NASA, but my advisor was interested. So that's why I had done that and focused on that. And so looking at that, I decided because actually the future work chapter was really good. Like all the things that I had dreamed about and imagined, which was having robots interact with clinicians and therapists in the hospital and interacting with older adults around rehabilitation. Of course, back then, 1999, this was not feasible in the real world, but now there were certain things in terms of computing and algorithms and hardware that this was feasible. The other thing that I've been doing all along, and this is from my NASA days, is I interacted through STEM workshops just in terms of access and ensuring that we had STEM, basically programming and lessons for diverse sets of kids. One of the things that I had also been focused on during that was expanding this concept of access, which is access for children with diverse learning needs. So whether it was a child who was visually impaired, that's what was my first kind of number of students that I interacted with, versus children who had motor disabilities. I had been doing, and again, more of like a side project, but I had been working on technologies and tools to ensure that my STEM camps were accessible. So it was basically, this was my hobby, right? It was like I was doing these STEM camps, I was making sure that our tools were accessible to all types of learners. And I thought, I wonder if I can combine the things that were in my thesis at the last chapter, which were futuristic, with this passion that I was doing, at night, on the weekends, on top of, outside of my research. I was thinking maybe I can do something in this space together. And so again, pivoted. So really quickly, and then I'm going to get into the future. Right now, we estimate about 150 million children diagnosed with disabilities that are worldwide. We actually think it's larger because some countries don't record it the same way that we do in the US, because services are not associated with recording. So there's some reasons for this. And what I do in this space is design healthcare robotics for children with special needs. primarily focused on motor disabilities, but also with developmental disabilities, children with autism, also children with learning disabilities, dyslexia, and aspects such as that. And so I'm not gonna walk you through that entire story because it's just as long as the NASA story. But one of the things that it caused me to look at was this fascination that I had about people, and people in the same space as robots and AI allowed me to really understand and figure out how to model people. And interesting enough, children are the hardest target demographic to model because they are really outside in terms of, we call anomalies, like every child is basically an anomaly. But what it's allowed me to do is really think about behaviors, think about AI, think about all of these things that then make it so that we have AI that can manipulate us. And there's reasons for this, and it's actually pretty easy to do. So I'm gonna talk about a little bit about the future of how I see AI and then talk about the things that I'm worried about. So as we know, with the future of AI, I mean, we have sensors everywhere, everything from our smartphones to the cameras that are outside. They're collecting data, and now there's this emergence of algorithms, artificial intelligence, machine learning. These systems are now doing things that are pretty useful and pretty helpful. And there's now documented, some of the papers are coming out that says with the onset of COVID, that the increased usage and adoption of AI and robotics has actually accelerated. So for those of us who were in AI, we were always like, yeah, AI, that's the tool, that's the future. But literally within the last 18 months, there's actually been an uptick of the types of adoptions. And of course, you can understand why. But what it's also done is it's made it so that there are tools and there's algorithms that are out there that are really not ready for prime time, but they have been integrated into our society as if they were. And so with it, there are some advantages, there's some positives, but there's also things like with anything, when you put out software that has bugs and we're not thinking about adapting them in real time, you also have some possible negative ramifications for certain individuals. So some of the things I'm excited about, one is this aspect of, given that there's all this data that's out there, we have smartphones, we have Fitbits, we have smartwatches, all of these wearables really can improve our quality of life. And because I look at healthcare, in fact, this is in that little infant, that's one of our infants. We do wearables for infants and preemies to do early diagnosis and intervention for determining whether a child might have a disability. So basically we're having kids, infants, learn how to exercise even at as early as 3 weeks. And so this goes all the way to older adults that are in the home that still need to exercise, that want to stay in the home. And how do you design these intelligent systems that provide an infrastructure to really help? And so that is an ongoing area. And the way that you can identify this is the number of startups that get VC and angel funding every year in this space, this AI wearable space, has again increased. And so for those of you who are into entrepreneurship, this is one of those areas that is really hot for investment and continuation. The other thing and the other area that I'm really excited about is thinking about AI data visualization and simulation. Because one of the things is, as we have this data, as it's being integrated, as we're creating these systems, the fact is that the data that's being collected is still, it's sparse compared to the world demographics. And so, of course, the US, pretty nicely covered, but rural parts of the US, not so. We know that there's some countries where very sparse number of data. And so even as these algorithms, even as these systems are being deployed to talk about, oh, but this models all the demographics of individuals, it really is only modeling certain demographics. And so the possibility is that when you add in data and simulation and visualization, you can actually have an attempt at trying to fill in the gaps. Based on very small sample sizes, you can augment. And so there's some powerful things around not just visualization, which I do some of, but also around language models for language that isn't English-based, where you might have small dialects or you have small samples in terms of what does this mean in terms of conversion, and being able to augment that with aspects. And so some positive things in this. The last two is collaborative AI, which is, again, this human and agent in this interaction. And that's really, I think, key. A lot of companies have realized that this whole concept of AI taking over is not as effective as when you have AI and humans working together and really modeling your systems and modeling your designs and your applications based on understanding that the human, as strange as we are, is still part of the equation. So how do you design your system to take the advantages of the human strengths and human skills to actually augment the overall efficiency of whatever it is, whether it's in the workforce, whether it's in the home, whether it's in education. And so this whole aspect of collaboration, whether it's called co-robots or human and AI collaboration, is really expanding. And it's not because as researchers, we've always said that this is important, it's because companies have realized that you can maximize efficiency and outcomes when you design your system, remembering that the human is part of this equation and this aspect. And then the last is this whole aspect of emotional AI. And not that AI can have emotions, but the fact is we are very social beings. And with COVID, we realize this even more. I love people. I love people because I like to observe and model them. I mean, during this time, I also realized, and I think most of us realize, that we also like to interact with people. I mean, sometimes we need our quiet time, but a lot of times we are social creatures, we have social norms, and the interaction really invigorates us. And so when we have these agents that are autonomous, for them to be fully interactive with us, they also have to understand our emotional state. And then they also have to adapt based on that. And so if we look at aspects of healthcare, which I'm in, but also even things such as workforce. So there's some really nice applications out there that actually can look at your emotional state and determine whether it's time for you to sit up and go get some coffee, right? Because if you're not at the right emotional state, if you're not engaged, if you're disengaged, that actually impacts how well you do in your classes or on your tests. And so having systems understand that and provide guidance in that aspect. And so there's a whole area of emotional AI, which of course then links to this aspect of manipulation. If you know my emotional state, then that also means that you know when I am more susceptible to manipulation or more susceptible to, say, buying that new purse that just appeared on my ad on whatever platform of choice that you have. And so this is the problem. AI, robotics, increasing in adoption, especially over the last 18 months. And with it, we understand that these aspects of collaboration and emotion have become key to designing systems that are really, in some cases, improving our quality of life, especially in healthcare and education, but also are being used for sometimes ill means in terms of manipulating and allowing us and pushing us toward one way or the other. And if anyone actually reads Twitter, which I do all the time, or Facebook, I mean, every week now there's some story about some AI algorithm or some company that has done something wrong and bad, but it really is focused on this aspect of manipulation. Because frankly, we're actually pretty easy to model, which is a good thing when it comes to like making sure that we all have equality and aspects of equal life, but it's also bad when you have individuals or bad companies that are looking at it for profit gain. And so I just want to talk a little bit about some of the things that I worry about. I'm a proponent of AI. I mean, I'd be out of a job if I wasn't. But I also know that because we are developers, because we know this area, we are also the best expert at trying to figure out how do we mitigate it? How do we actually design the solutions that can balance the possible negative impacts while enhancing the positive? And so talking about a little of this aspect of bias. And so one of the areas, although I'm an application-based, I do this healthcare, I was doing science-driven robotics. Because I do healthcare, I've had this real deep dive on modeling people and also in trying to understand this aspect of bias and aspect of overtrust. And I can give a whole talk about how people trust these systems. Unfortunately, we do, which helps in certain applications like healthcare. I want you to have medication compliance, which is good, but it also means that we tend to do things like drive our self-driving cars into a truck. Same kind of concepts, has these kind of different results. And some of this is driven by our biases. So I'm going to talk to you about two examples through my own research and then things of how to mitigate. So emotion recognition, I talked about emotional AI, in pediatric robotics, we use emotion quite a bit. We use it to identify whether children are engaged in the intervention with the robot or they're disengaged. And so what that allows us to do is it allows us to adapt the protocol. So if we know that this is disengaged or that the child is getting frustrated or happy, we can have a different outcome so that we can, our whole goal is to keep the child playing as long as possible, because this is intervention and this is rehabilitation. So we have focused a lot on identifying the emotional state of a child. Now, when I say emotional state, it is facial recognition, emotion recognition. There's aspect of body and language, but that's set for another talk. And so what happened was, when we started in this space, I didn't do emotions. Like, I did algorithms, I did learning. I didn't do emotion and sentiment. And so very early on, we would take, basically open source off the shelf cloud APIs and say, okay, this is great, let's just apply it. I mean, that's what it's used for. And very early on, we realized that it wasn't working for our application. And so this was our first dive into understanding, how is it that you have these applications that are out there? In some cases, having a price tag where you have to actually pay for it, and yet it wasn't working with our target demographic. And there was no disclaimer. It was no like, okay, here's a disclaimer that it doesn't work on kids that are 5. I mean, after a while, you're like, oh, okay, I understand why, but there was no disclaimer. And so we started doing a deep dive into this and really trying to assess what are the biases, because in healthcare and working with children with special needs, mistakes are costly. And so it couldn't be like, oh, it didn't do it right. It's like, no. It does not have the option of not doing it. It has to do it right. And so we did a lot of assessment, and what we found, and there's a lot of information out there in terms of biases with respect to gender and things like that. But basically, if you have any feature, characteristic that is different than the majority, it will not work on you, right? And so for us, we were looking at age. And of course, younger kids, it doesn't work that well, and it makes sense. If you think about these systems, especially machine learning systems that are based on scrubbing the web, where do you get pictures of 5-year-olds that are frustrated or angry? Parents like to post happy pictures, right? So it's understandable why these systems that are trained on all this data aren't representative of what we need, but it also applies to older adults. And so if you think about the fact that hopefully everyone ages. As a developer, you are creating software. Eventually, you will be the target of this software, that if these systems don't work for everyone, it means that at some point, someone in your family or you yourself will be basically a victim. And so this is a thing of then, for my students, I always say, look, don't you want this system to work for you 30, 40, 50 years now? Then you need to think about how do you fix it now, while you basically don't have you are not a victim at this point. And so this is the perfect time to think outside the box and think of, how can I actually do it? And so I know and that we can fix this. And so my group has really delved into what I call the specialized learner. So a lot of times we talk about generalized, like we want things to be generalized learner so that it works for all people. But the fact is, because I've interacted with so many people, especially kids, I mentioned kids, they're all anomalous. The fact is that we are all anomalous. We all have special features. And so when we design these AI systems, there is some general function in terms of modeling, but there's some characteristic that is different. And so we design, at least in my group, we design learners where there's a generalized model that gets us, pretty close, but then understanding the unique characteristics that maybe it's around gender, maybe it's around ability, maybe it's around race and ethnicity, to actually add as a hierarchical level so that you get the benefits of all the data that's out there, all the machine learning, all the data sets that are available, some of them free, some of them not. But then when you have the small sample, because we're all unique, you can actually still have the exact same outcomes across all the different target demographics. And so we've done it with respect to computer vision. My student just did it with language models. I'm so happy. He's about to present next week about this aspect of thinking about people as fundamental, as core, and the differences that we have, that diverse experience that you bring to the table, designing our algorithms to actually understand that, incorporate that. The last one I'm going to talk about, and then I'm going to let you ask questions, is around gender biases. And so this is more talking about us as developers. So a lot of times there's been research that shows that as we design these AI systems and robotic systems, we tend to add gender to them. Because the concept is there's social norms, which I talked about. So there's this understanding about if I have an agent that understands social norms, why not? And so what we did was we decided to do a study to really test that, to in some cases validate it. But what happened was, just in general, there was this concept that when you have a disconnect, so a cognitive mismatch between the gender of an AI agent and the role that they should have, that you don't necessarily trust them as much, or you won't follow their guidance as much. So as an example, if I expect a teacher to be female and a male gendered robot or AI agent comes, I'm less likely to trust. So that's what some of the prior research has shown. And knowing people and knowing and interacting with all these kids, I wanted to push back a little. I didn't know what quite, but I wanted to push back. And so our concept was that maybe a neutral robot would actually resolve all of this. And so we designed basically a male gendered, a female gendered robot, a neutral robot, and we assigned them different tasks because we wanted to prove the mismatch. And then what we wanted to do was mitigate it. So that was the whole effort on this. And one of the things that we found, which was quite interesting, was that when we first identified the gender of the robot, so this is basically our check, as developers, did we define it as female gendered? Did our participants say, yes, it's female gendered? And so for male gendered and female gendered, it was great. But for neutral, most individuals identified it as male, which was actually very curious because as you know, most assistants, at least in the United States, are gendered as female. So this actually confused us because like if you look at all this, why is this the case? Why do most people, if it's neutral, identify it as male, even though we have the Alexas and the Siris and all these gendered voices that are primarily female out of the box? And so looking at this, we were like, okay, our hypothesis about this cognitive mismatch is going to go out the window. Like we have no idea what's going to happen if people actually think that all robots are male and they're just hiding it. And what we found is that when we looked at these male and robot and neutral roles, at this point, our hypothesis, you're like, we have no idea. There was no difference. And so what does this mean? So what it means is that when we think about gender, and we did this across race and ethnicity too, just so you know, just trying to push this, is that we have developers, we have had these assumptions about gender and about race and ethnicity in terms of our AI agent because we're trying to think about social norms. But the fact is that when people interact with these agents, they see them as agents. They see them as socially intelligent agents, but they don't see them as human. And it's us as developers that are actually trying to basically put attributes or assign attributes to them because that's what we're thinking. And that's what some of the literature says. But if you continue deeply diving, and I've gone deep dive on this, it's like, well, why is it that most female assistants, robot assistants, have gendered voices? If you look at this, a lot of it has nothing to do about social norms. A lot of it has nothing to do about, well, people actually react better. The fact is that there's some biases that have crept into our development processes, and we have just propagated some of these things in terms of the data set. So now we have tons of data sets with female voices. So of course, we're gonna train on female voices. And we have all of this data that says, well, people will follow Siri with the female voices versus Siri with the male voice. Well, it's because we have been conditioned now to listen to these gendered voices that are typically female. And so what that means is as developers, we've actually started to warp our own social norms because of our misconceived notions. And so I can do a deep dive on both our studies and some of the research that we've done in this area. But what I say is that I think when we think about this aspect of having hope is designing the algorithms to focus on people, to focus on the fact that at core, we're trying to design AI to enhance our quality of life, to really push forward. And so it's not just about the agent, it's just not about the AI, it really is this interaction and that people are special and interesting, but that they are core for this. And so as we're designing solutions for them, we should also ensure that there's equal outcomes across all target demographics. Again, people as a unit. And the other is the focus on diversity. And when I say this aspect of diversity, we are all humans, and so there's some generalization that we can make, but then we also have these unique characteristics from our learned experience, from our attributes. And so those are the things that we should also focus on when we're designing the next generation of AI and algorithms. And so I think when we design these systems based on people and diversity, we can enhance the benefits of AI, but also mitigate any potential biases that come out. And I really think it's our responsibility. One of the things I worry about is that if we as computer scientists don't lean into this, that someone will decide it for us. And when someone decides it for us, they will not be computer scientists, they will not be engineers, they won't understand the nuances of the algorithms and how things can and can't be done. And so by us actually coming up with solutions, then maybe we can actually figure this out before things are imposed on us, which is kind of what's starting to happen. And so with that, I am done. I will open up for like very few questions, but I like talking about this stuff. And you see, I'm kind of a smorgasbord of all these kind of things, but I love every minute and every bit of it. So with that, thank you.
Thank you, Dr. Howard. Such an exciting presentation. So we do have time for questions. If we get questions in the Q&A from the Zoom, Simon Akhtar in the back will help us moderate those. So if you're on the Zoom, please feel free to put your questions in the Q&A. And if we have questions in the room, we can navigate those from up here. Let's see, we got one in the back.
Oh, okay. Hi. So you talked about how people inherently trust AI and how everybody kind of has these biases. And so like the people who are creating these algorithms also have these biases. And obviously diversity is something that can help mitigate those biases. But like what should we do between the time lapse of like increasing diversity in people who create these algorithms and people who can inherit, and with like now how people inherently kind of trust these systems to help us, even if it might not necessarily accommodate certain features of ours, like in between that time of like increasing diversity in the algorithm space and us now just kind of trusting these systems that may not be there to actually help us.
Yeah, so there's two aspects of this, and I have solutions on both sides. So as a developer versus what I call as a user. So as a developer, I think if we believe in this, we should be comfortable with having a voice. And how we express that voice, it could be based on your style. So as an example, if I'm in a room and I see that there's no mention of abilities, I'll say, you know, what about abilities, right? Even though this is my research, I don't have a disability, but I will say that. And so the thing is, it's so much easier to talk up for someone else than it is to talk up for yourself. And so whenever you're in a room, you know, think about, okay, who's missing? That's not me. And just talk up. And I think if we all do this, eventually people will start thinking about it. So that's just on that. And so that's one thing. On the user side, I actually challenge us as users to really try to break these systems. Like when we have, like, for example, search engines, every time I'm on a search engine, I intentionally, takes time though, right? Which is inefficient, but I intentionally don't do something on the first page. I intentionally go to the second and third page and click on something, right? And why is that? It's because if you think about it, we are all conditioned, and there's been research, we're all conditioned to, you know, look at the first page results. Typically, you know, the first, second, and third have like 70% and it goes down. And they've shown that studies is like they can reverse and take fifth and put it, and people will still be like, oh yeah, that makes perfect sense, click. And so, you know, as users challenge the norm that's coming out from these algorithms, this software and things like that, inefficient because it's like, oh, wait, hold it. I do search because I get an easy answer. But it also, if we all did this, then companies would actually start thinking about, oh, maybe we need to think about mitigating and fixing this. And so those are kind of two of the suggestions. There's a lot more, but some of the basic suggestions. Thank you for the question.
In the field of causal inference in Judea Pearl, are you applying any of that to your research, or know of anyone applying that to research along the fields that you're interested in?
In some of the, I will say in some of the NLP work, so I don't in my own group,
okay,
but in some of the NLP work that's looking at mitigating bias, someone at Cornell actually looks at this. Right. I was looking at you, Julia, maybe you know. So yes.
questions from the Zoom? Okay, I have a question. So, and this is a question I've gotten as someone who works in cybersecurity, and I thought of it when you were talking about trying to study and understand the ways in which robots can be used to manipulate humans into trusting them unnecessarily. So the question that I get as a security researcher, I'm going to pose to you in your context. Don't you worry that by understanding how you can manipulate people using robots, you're going to encourage and allow people to use this information to manipulate people using robots?
So yes. In fact, we're doing some research on deception right now. How do you get robots to lie effectively? But I also know, just like with anything, any technology we have out there is dual use. And dual use basically means if I create it for good, it can be used for bad. And it could be a pencil, right? It doesn't matter. I can take a pencil, I can poke out someone's eye, right? And so every technology, if we think about it as dual use, it also means that as we think about dual use, we think about the good, but we also can think about what safeguards can we place so that the bad is really, really hard to do. And so if you think about a pencil, a lot of times, most pencils, if you notice, back in the day, they would come out with really, really, really sharp ends. Now, if you notice, a lot of pencils, they're kind of a little bit dull, right? So a kid who just opens it up can't poke someone's eye out with it. And so there's some of these kind of mitigating things about how do you make it harder to do bad.
Great, absolutely.
I was wondering if you have any advice for reaching out across disciplines and to find problems outside your discipline. So you were very successful with that. And before your work well done enough, do people come to you and problems come to you? How do you do that? How do you reach out and find problems in your experience?
Yeah, so I would go out. And so I would kiss a lot of frogs, honestly. So when I was doing the science-driven robotics, the way that I found the problem is I went to science conferences and I would sit there and listen to geologists and climatologists, and like half the time I was like, I have no idea what people are saying. And then finally it was like, oh, I would talk to someone like, yeah, no, I'm not that interested. And when I did the healthcare, I did the same thing. I started going to conferences in medical surgery and there, and again, they were talking about anatomy and I was like, I have no idea. And eventually I was like, oh, like we actually sort of can talk. I don't understand you, you don't understand me, but it seems like we can go somewhere. But you have to feel uncomfortable.
So there's someone on Zoom that has a question named Tyler. And Tyler's question is about your thoughts about meta AI that analyzes in-process AI software to find areas of improvement and recommendations as it relates to the improved ethical development of the system.
Yeah, so just in general, this is, so when you have an AI system that is conclusive, there's actually these processes of the in-betweens, basically the in-betweens. And so there's some algorithms that think about, can you, so think about with machine learning, if you can table and figure out at the layer level and do something and figure out what the errors are at that level versus when it comes out and do something interesting, then maybe you can actually fix it. I will say that in theory, I've seen it working really well, but I haven't actually seen it really working well in a generalized application, just in general. And so that's not to say that it can't be done, but yeah.
All right, so before we give a final thank you to Dr. Howard, I invite those of you who are in the room to stick around a little while. We have a meet and greet. Normally we'd have a reception with food and drinks, but it's not time for us to do that just yet. So, but you can at least have a little bit of time together and speak to her and social mingling, distance mingling, maybe, I'm not sure. But that's for those of you in the room. We'll be ending the Zoom. So before we do that, thank you to all of you for attending. And please join me again in thanking Dr. Ayanna Howard for this excellent presentation.